Hello everyone and welcome back to my channel. It's been a while and I miss YouTube. So today is going to be the first episode of the AZ-204 study cram where I'm planning to go through the entire syllabus to help you pass the exam. AZ-204 is a very tough exam, so I'm going to try my best to explain things with simplicity and with as many examples as I can provide as usual. So if you find value out of this video, please like this video, subscribe. It would really help in growing this channel. So throughout the video, I'll be changing my shirt multiple times, so just don't be surprised by that because I'm going to actually film this across many different days. So with that out of the way, let's just get into it and hope you guys enjoy it. So we will start off with the first section of the exam, which is develop Azure Compute Solutions, and that forms 25 to 30% of the exam, which is actually the bulk of the exam. So what I'm going to do is I'm going to keep a copy of the syllabus right here at the top so we can make sure that we go through the syllabus one by one and have you guys covered for the whole exam. So under that section, we have four main topics, starting with IaaS and ARM templates. Then we're going to move to containers, then Azure App Service, and last but not least, we'll talk about Azure Functions. So starting with the IaaS and ARM templates, we have the section of provisioning virtual machines. Now, this exam is not really heavy on the virtual machines part, but there are some things that you need to take into consideration. So when we talk about provisioning virtual machines, there are a couple of things that you need to think about, or design considerations that you need to think about before creating a virtual machine. Now, the three factors you have to take into consideration are the CPU you have, the memory you have, and the IOPS. So the CPU is very useful for obviously process intensive tasks. So you want to choose a virtual machine that is compute optimized, which means that it has a higher ratio of CPU to memory. Or you can use a virtual machine that is memory optimized. So for example, a lot of times people use databases that are memory optimized because you typically want a memory optimized database. And then last but not least, you need to take IOPS into consideration. And IOPS is nothing more than just a unit of measurement for the SSD and the HDD. So those are the three things that you need to take into consideration as a developer if you want to develop applications on a standard IaaS virtual machine, which is, by the way, never a good idea. So moving on, the second topic I want to talk about super quick here is just the high availability. Again, as a developer, when you are developing applications on a VM, which is not a good idea, you need to think about high availability. So on Azure, we have like three ways to achieve high availability of your applications that are hosted on virtual machines. So the first thing is the availability set. The second is the availability zone. And the last one, which is not really part of the VM out of the box features, but you can use a separate service on Azure called Recovery Services Vaults, where you essentially back up your virtual machine into a separate region. Again, I'll go through that in detail. So starting with the availability set, the availability set basically places your VM into different racks in the same data center. Okay, so if there's a network failure in a specific rack, or if there's a hardware failure in a specific rack, your application will still be available because your VM is placed in a different racks. So this is availability within a specific data center. Now, when we talk about availability zones, your VMs are replicated across different data centers in the same region. So the way this works is for a specific region, let's say it's West Europe, we typically have a lot of different data centers, typically 3 or even more. And the way this works is Microsoft places your VMs across those data centers in a specific location. So this does not provide regional high availability. So meaning that if one whole region goes down, that does not mean that the application is highly available. What this means is that if a specific data center is down, but not the whole region, then the application will still be highly available. So this is the concept of the availability zone. And the last one was with the Azure site recovery. This, with that, you basically have to rely on another service on Azure called Azure Recovery Services Vaults. And that would allow you to essentially replicate your machines across different regions. So if you're super paranoid. Let me go through the portal real quick and show you how we configure those settings. So under the create virtual machine part, you obviously have to specify the resource group and then you choose a name. And under the availability option, you can opt to not have any infrastructure redundancy required. Basically, you won't make use of the availability set or the availability zone or any of the things we discussed. Or you can choose either availability set, availability zone, or virtual machine scale set. So with a virtual machine scale set, it actually places your VMs behind a load balancer, so kind of giving it that high availability. So again, this probably explains it much better than I did. So with availability zone, it physically separates your resources within an Azure region, so across data centers. Availability set basically distributes your VM across server racks, which is what we call fault domains. So this is really how you configure the availability types. And on the Azure documentation, I will share a link below. We have some examples of VMs that are compute optimized, that are memory optimized, maybe that are general purpose, etc. So those are the things that you have to take into consideration when you are provisioning virtual machines. So moving on to Azure ARM templates, and you are expected to configure and validate and deploy ARM templates. But before I go deep into ARM templates, I just want to take a step back and talk about operations on Azure. So on Azure, we have two distinct types of operations. The first one is the control plane operations, and the second one is the data plane operation. So the control plane operation is basically the management operations. So what we call CRUD operations, the create, read, update, and delete operations. So when you create a storage account, for example, that is considered a control plane operation. On the other hand, for the data plane operation, those are specific functionalities exposed by a service. So for example, when you RDP into a virtual machine, that's a specific functionality exposed by a service, but it is a data plane operation, not a control plane operation. When you delete a virtual machine, that's a control plane operation. So on Azure, it is super important to distinguish between the control plane operations and the data plane operations in order to properly understand what an ARM template is. And on Azure, we have the concept of resource providers. So resources on Azure are organized by resource providers. And under each resource provider, we have a set of control plane operations and data plane operations. So in this specific example, we have the Microsoft.Storage resource provider, and under that resource provider, we have hundreds of operations, being control plane operations or data plane operations. And actually, in this specific example, this operation here is actually a control plane operation, but this one here is actually a data plane operation. And if I want to go real quick to the documentation, just to show you a list of all operations under all resource providers. So if you go to this link, and I'll provide it in the description, you can see that under each resource provider, we have a lot of different operations. So here in this documentation, the data plane and the control plane operations are not really distinguished. So you might ask me, okay, so how do we distinguish between a control plane operation and a data plane operation? Or in other words, how do I know if this is actually a control plane operation or a data plane operation? And the easiest way to do that is actually if we go to the portal, and then if you go to access control, so this is a specific storage account. If you go to access control and then to the roles section, there's a role here known as blob reader. So if I click this role itself, notice that we have actions and data actions. So under actions, we have the control plane operations, and under the data actions, we have the data plane operation. So this specific permission is actually considered a data plane operation, while those are considered a control plane operation. Now, if you want just something a bit more intuitive and maybe a bit easier for you to know about, typically, let's say 90% of the time, and again, this is not a hard rule, there are some exceptions, anything or any operation that is logged under activity log is typically considered a control plane operation. Anything that is not logged in Azure activity logs is typically a data plane operation. So when you are actually reading from a blob storage, that's not going to register an activity log event, okay? Because that's a data plane operation. Anything else should typically register an activity log operation. Again, that's maybe 95% of the situations. I believe it is good enough for the purposes of this exam. So that brings us to the question of what is Azure Resource Manager? Azure Resource Manager is the control plane and management plane in Azure. So any operation, any control plane operation actually goes through Azure Resource Manager. So any operation, whether that's done through the portal, through the CLI, through PowerShell, or through a REST API, obviously you guys know that anything you do on Azure at the end is just an API call, whether that's done from the portal, whether that's done from a script or from your application, everything is essentially an API call. And all control plane operations go through Azure Resource Manager. So And again, that's why I mentioned the resource providers, because under each resource provider, you have specific operations. So if myself from the portal, I want to find out the list of operations under a storage account, my portal would actually call the Azure Resource Manager, which then calls that specific operation under that specific resource provider. So the reason why we have this middle layer is because it deals with things like authorization, RBACs, and things like that. So again, any control plane operation will go through Azure Resource Manager. So anytime you are creating resources, this will go through Azure Resource Manager. Anytime you are reading resources, go through Azure Resource Manager. Anytime you're deleting resources, it goes through Azure Resource Manager. So now the important question is, what is an ARM template? So again, just like on the portal, you can create Azure resources, okay? Or you can create Azure resources using PowerShell, CLI. An ARM template is simply just a declarative way to create Azure resources, okay? So again, creating Azure resources is considered a control plane operation, okay? And that goes through ARM or Azure Resource Manager. You can create those operations, or you can access those operations through the portal, through the CLI, or through the REST API, but you can also do that through an ARM template. So with an ARM template, you basically declaratively define what resources you want, okay? Declarative means like you typically write that in a form of a JSON file, a YAML file, etc. In this case, it's a JSON file. So you declare what resources you want in advance. That's what we call declarative, okay? Now, the advantages of using something like an ARM template is, first of all, it is declarative. So the reason why it's important to have something declarative is because you can replicate the same template across different environments, okay? So you can have the same template be applied to a test subscription maybe, or a test resource group, and then you can have that same template be applied to a production resource group or a production subscription. So that's just because it is declarative, it makes things like replicating across different environments so much easier. Next, it is version control. So that's another huge advantage. So you can track the changes to this declarative file on things like GitHub, Bitbucket, GitLab, and all of that. So it is version controlled. It's always good to declaratively define your resources. Actually, this is best practice when you are going in production. So if you want to adhere to the principles of infrastructure as code, this is what we mean by infrastructure as code. So you are defining your infrastructure in a declarative file. So in this case, it is an ARM template, okay? Now, what are those sections in the ARM template? So again, this is just a JSON file, but there are certain properties that you need to understand. So under the schema, this is basically like built in. You can get it from the documentation, and basically this defines the properties available for this template. So under this specific schemas, you can define certain properties like variables, parameters, resources, etc. This is standard across every single template. Then we have the content version, and this is if you want to version your template. So if you want to have version 1, version 2, etc. If you want to make changes, that's a good a property to take into consideration. Then we have parameters, and parameters are simply just a way to allow you to provide inputs to this template, okay? So again, a big advantage is that this template is declarative, which means that it can be replicated across different environments. So you can parameterize things like the resource group. So you can provide the resource group as an input because this is what you want to change across different environments, okay? Again, this is just a way to provide inputs to your template. This is the easiest way to think of a parameter. And for variables, this is when you don't want to hardcore things like let's say the resource group location, things like that. You want to store those in a variable because you will be using them across different resources. So variables, again, this is intuitive. The most important section is actually the resources section. And as you can see, this is an array of JSON objects. Okay, and this is where you actually define the resources that you want to create. So in this case, we have the storage account, and this is, by the way, all taken from the documentation. So I don't expect you guys to actually memorize every single thing here. This is all taken from the documentation. But if you want to create a storage account, you would have to put that under the resources array. Okay, and if you want to create more resources, you just have to add to that array. In this case, I'm just creating a storage account. You would provide the name, which is in this case storage account 1, and then the type, which is the resource provider / storage account, and then the API version. Again, that's taken from the documentation. And then here you would provide the location. And the reason why I'm highlighting this is because anytime you see a square bracket in an ARM template, that means that this is an expression. Okay, what do I mean by expression is just it's a way to easily access a specific object. So in this case, in order for me to easily access the resource group location object, I need to wrap this around a square bracket. Okay, so again, here instead of typing, for example, West Europe, so instead of hard coding that, I can just type that I want the resource group location. So I want the storage account location to be the same as the resource group location. This is an example of an expression. There are so many other different expressions. Those are all linked in the documentation. Then we have the tag section, obviously, if you want to tag your storage account, and then just the standard properties. In this case, what account type am I choosing? And last but not least, there's the output section. And this is if you want to define a specific output from your template. Typically, the goal of the template, again, is not to really specify an output. It's usually just to create resources on Azure. In this example, it is a storage account. And by the way, when you deploy this template, behind the scenes, it actually converts that into a series of REST APIs. Because again, anytime you are creating a storage account, at the end, this is a REST API call, whether that's from the portal, whether that's from PowerShell, and even from an ARM template. So when you deploy this ARM template, it actually creates those REST API codes behind the scenes for you. Okay, so this is just a fun fact. And if I want to go through a quick demo here, I just want to show you a quick example. So this is an example that I took from the documentation that will allow me to create an API management service. Okay, so under this template, again, the schema is just standard, the content version. In this case, I don't want to version my template, so I'm just going to keep it as it is. The parameters section, under that parameter section, we have a list of parameters. So in this case, I do want to provide inputs to this template because I want to replicate this across different environments. So I want, for example, the API management service name to be different in the test environment than in the production environment. So I am parameterizing that. Okay. Of course, here you can provide default values for the parameters. So if you did not add any value, or if you do not provide an input to this template, it would just choose a default value. In this case, again, there's a square bracket, which means that it is an expression. And here I'm just creating just a random name for this API management service. And then the publisher email, I have another parameter, publisher name, SKU, and all of that. Again, I don't want to go through those one by one, but it's always useful to go through that in a live example. And under the resources section here, I want to create an API management service. So I'm going to have an API management resource here. So again, I specify the type, the API version, all taken from the documentation. The name is actually taken from the parameter. Again, I would have to use an expression for that to tell the template that I'm using this from a parameter, and the location and the SKU, the properties and all of that, all of those are from parameters. Okay. So now what I can do is if I want to deploy this template, I can use PowerShell or I can use Azure CLI. In this case, I'm using Azure CLI. So what you would type is AZ deployment group create, and then you would type the name of the deployment itself. So that's not the name of the resource. That's just the name of the deployment. Every deployment is just going to have a name. In this case, I'm specifying a name of test. And then you specify a resource group. And in the case of ARM templates, you can either deploy that template into a subscription or a resource group. The best practice is to actually deploy it into a resource group. In this case, I'm deploying it to this specific resource group. And then I'm specifying the template file, which is arm.json. And I am specifying a parameter file. So here under the -- parameters section, I can explicitly define the parameters right here from this command. Okay. But the best practice is actually to provide those parameters in a separate parameters.json file. Again, this is taken from the documentation, but this is the syntax on how to do it. So you would actually define the parameters. In this case, I'm defining the API management service name of that. Okay, and the publisher email, publisher name, and the SKU, I'm doing that from a separate parameter file. And then I'm supplying that parameter file to this command here, or to this deployment. And if I click run, it will actually create an API management resource for me. I'm not going to do it because I already did that, but I just wanted to show you guys a live demo of that. Next, we have the concept of a multi-tiered template, and I've saw a couple of different questions on this section. But what you need to know is you can basically nest template under a parent template. Okay, so for example, if you want to be creating multiple resources under the same ARM template, the best practice is not to put every single thing onto the same template. The best practice is actually create separate templates for each resource, and then have a parent template that calls those nested templates. In this example, I'm creating a virtual machine, an app service, and a SQL database into a specific resource group. Now I can have all of those under the same ARM template, or I can have them under different ARM templates and have a parent template call those nested templates. Just wanted to highlight that because I saw a couple of different questions on that on the exam. Then we have the deployment mode, and we have two different deployment modes with Azure ARM templates. The first one is the incremental mode, and this is actually the default one. And what this means is that this will leave resources in a resource group or subscription, depending on what you specified. This leaves them unchanged if they aren't described in the template. So let's say I have a template that creates a storage account, okay, under a resource group. Obviously, if I have virtual machines under that resource group, or if I have SQL databases under that resource group, I want those to be unchanged because in my template, I'm just creating a storage account. I want to leave everything else the same, okay? This is the incremental mode and the default mode. However, sometimes you want to have, like, let's say, a single source of truth for your ARM template. You would go with the complete deployment mode. So what this means is that if the resource is not in the template, it actually gets deleted, okay? And in order to do that, you have to explicitly specify the mode with -- mode complete, because the default is the incremental. So be careful. If you are using the complete deployment mode, it will literally delete every single thing in your resource group if you did not specify it in the template. Now let's move on to what is a container. Okay, so I've made a detailed video on what a container is, and I talk about Kubernetes and AKS. So make sure to watch this video. I'll link it here at the top. But in a nutshell, what a container is, it's just a layer of abstraction above a virtual machine. So you know, with a virtual machine, you have the concept of a host machine, and then you have the concept of virtual machines being built on top of that host machine. Each virtual machine is going to have its own guest operating system. The difference between a container and a virtual machine is that you don't have the concept of a guest operating system. So there's no guest operating system. It's much more lightweight. It packages all the dependencies together into a single container, so we can run it across multiple environment, and it is the de facto standards for microservices. So anytime you are developing microservices, you would have to be using containers. But again, like, the main benefits is that it is lightweight and it packages every single thing into one container. Okay, and again, I made a detailed video on that. Please make sure to watch that. But if you want to create a container, okay, there's a specific workflow that you have to follow. And again, there are a couple of different questions on the exam about how to create containers, or what is the typical format of the file. In this example, I'm going to go through a quick one, which is a Node.js application that I want to containerize or create a container out of. Here at the top, you would have the base image. So think of, let's say, if you want to install let's say any application on your operating system or on your machine, you would need to have an operating system at the top. Okay, so you just can't just install, for example, Microsoft Edge on a machine with no operating system. So you need to have a base operating system. This is the same in a container. You need to specify a base operating system. In this case, it's Node 16. It could be a Ubuntu machine. It could be anything. Okay, so this is, again, the base operating system. Here, there's just a series of commands that you have to go through. So the first one is I'm specifying a working directory for my application. So I want my application to be inside this directory in a container, okay? And then I'm just copying my package.json file, which has all the dependencies. I'm installing all the dependencies. And then I'm copying every single thing from my current directory and putting it into the working directory. This is what it means here. Here I'm exposing port 8080, and then I'm running the startup command. Okay, so the startup command is the command that runs your application. In Node.js, it is node and the file name. Okay, so this is the startup command. Again, in my other video, I actually explained the container as being a file system snapshot. This is exactly what we're doing. We're literally just copying everything from the directory, putting it into a specified working directory that I specified. I'm copying, I'm installing all the dependencies, and I'm running the startup command. Let's see this in a live demonstration. So here I have my application folder. It's a very simple application, but if I want to type npm start to run my application, this application is actually running on my local machine. So if I go to the browser and I type localhost 3000, I will have this working application. But again, at the end, it's running on my own personal laptop, okay? What if I wanna have this application run inside a container, so not on my machine? I would obviously have to containerize it, and the most popular platform for that is Docker, so just make sure you have Docker installed. The quickest way to check if you have Docker installed is just type Docker, and if you see those help commands, that means you have Docker installed. If not, you need to install it. Super easy, just do the quick search on the internet. So the way to create a container out of this application, or the way to containerize this application, that's the correct terminology, is to define the Docker file. And again, I went through this in detail, but in this case, again, I'm specifying base image, work directory, I'm copying the dependencies file, and I'm installing all the dependencies, and then I'm running the startup command, which is npm start in my case. Okay, so now if I want to apply this Docker file into my current directory, I would type docker build -t, and what I'm doing is I am actually tagging my my build, or tagging my container with this specific name. Okay, I don't want just a random GUID, I just want a specific name, and there's a reason why I chose this specific name. It will make sense later on. And then I specify the current directory I am in with the dot, which is everything under my current directory. So I type that, and then let's wait for that to run. And now I should have an image with this name, okay? But I need to run an instance out of this image, okay? Again, there's another definition for a container. It's actually an instance of an image, okay? So right now we have the image. We need to run an instance out of this image. So what I would do is I would type docker run, and then the name. So .azure.cr.io test v1. And by the way, something I forgot is when you type docker run, you need to expose the ports here. So what I'm doing here is I am exposing the ports in my container, because otherwise I won't be able to access this container that is running locally. So what I'm saying here is expose my container on port 443, and my application is listening on port 443. Which is the case here. My application is listening on port 443, but I want to access the container on that port as well. So this does like a port mapping, super important. Then if I click run, as you can see, app is listening on port 3000. Now my application is actually running inside the container. And if I go back to the browser, I can see that the application is still working fine. But the difference is that previously my application was running on my local laptop. Now it's actually running inside a container. So right now I have my container running locally, or I have my container image running locally. Obviously, this is not the best practice. You always want to store your container in what is known as a container registry, which is a centralized place to store your containers in, okay? This is super important because if you want to get into things like Kubernetes, a service like Kubernetes is actually going to pull containers from a centralized container image registry, okay? So right now I have my container image stored on my local laptop, but I do want to push that into a centralized container image registry, okay? The way to do that is we can use a service called Docker Hub, or if you want to use an Azure service, it's called Azure Container Registry. I will explain more about that in detail, but let me go through a quick demo because this will make much more sense. Okay. Now, the first thing I have to do if I want to push this container image to that centralized repository on Azure is I have to type AZ login to make use of the AZ command line and to authenticate to my Azure Container Registry. I'm not going to do that. I already did, but make sure to run AZ login before doing any of the subsequent steps. Then I would type AZ ACR login and the name of the Azure Container Registry resource. Again, I'm going to explain that resource in detail later on, but I just want to go through a demo super quickly. So here the login succeeded, which means I am authenticated to the Azure Container Registry. This could be a Docker Hub, by the way, or any other container registry service you are relying on. Then all you have to do is type docker push and the name of the image you have locally, the one that I tagged. Okay. Now the tagged image I have is, pardon me, it is this one. So docker push the image that I have that is tagged. And if I type that, it is actually pushing this to Azure Container Registry. Okay. So now if I go to the portal, I have a container registry resource created on Azure. And under the repositories section, I should see the image that I pushed. And as you can see, this is the image that I actually pushed, and it's with a specified version that I have. So now my image is not stored locally on my laptop. It is stored in a container registry. In this case, it's Azure Container Registry. Now, under Azure Container Registry resources, for the purposes of this exam, you need to concern yourself with two things. Firstly, the pricing tier and just the storage capabilities of Azure Container Registry. Now, we have a couple of different pricing tier. The first one is the basic pricing tier, and here you don't have a lot of included storage, an image throughput. What do I mean by image throughput is, again, when you start dealing with things like Kubernetes, container instances, things like that, in order to create instances out of the images stored in that centralized repository, there's a certain image throughput, because sometimes that takes time to transfer that image and create an instance out of it. So that's known as the image throughput. In this case, you don't have much of it on the basic tier. Again, this is just meant for developer workloads, not for production. The standard provides more storage and image throughput, so that's a different, and this is actually meant for production workloads. The last one is the premium feature. This adds all the features of the standard, but it adds extra features like geo-replication and private link support. So with geo-replication, you would actually have your images replicated geographically across regions. So if there's an outage on this specific region, your images are actually still going to be available. Again, this is part of thinking about your disaster recovery and high availability strategy. Last but not least, there's also private link support. I will be talking about private link later on in this module, but I'll leave that here for now. And then we have the storage capabilities of Azure Container Registry. So those are the standard storage capabilities across all the tiers. So what you will get is encryption at rest storage. So everything is encrypted at rest on Azure Container Registry. And then you have geo-replication of storage, obviously if you are using the premium tier as discussed. And you need to know that the limit of storage is 5 terabytes, which is actually a lot. Last but not least, in the topics of containers, we have Azure Container Instance. Now, an Azure Container Instance is a resource on Azure that allows you to run containers in a serverless way. So if you are familiar with Azure Functions, where you can run your function in a serverless way, Azure Container Instance is a serverless service on Azure that allows you to run containers on it. Now, you might ask me this question, and this is a question I asked myself a lot. Okay, so why do you have Container Instance, which is a serverless way to run containers, if we can run containers on Azure Functions? So what is the difference? And the difference between those two is Azure Container Instance is typically used if you want a long-running application or a long-running container. With Azure Functions, it's typically shortly executed processes. Okay, so you just want a specific thing to be executed. You can package that into a container, throw it into Azure Functions. But with Azure Container Instance, it's also serverless, but it's meant for long-running containers. Like you can host a whole application just on Azure Container Instance. Okay, so again, that's the difference between running a container on Azure Container Instance or on Azure Functions. Now, under Azure Container Instance, you have the concept of container groups, which is a way to deploy multiple containers in a container group. Okay, typically in a container instance, you just run one single container. Okay, but with the concept of container groups, you can deploy multiple containers into the container group. This is very similar to the concept of a pod in Kubernetes. So again, I have another video that goes into details on that, so make sure to check it out. Lastly, we have stateful containers. So by default, Azure Container Instance is stateless, which means that there isn't a way to store local information. So you can't write things into a variable, you can't store session information, you can't write into a local cache, things like that. So in order to do that, you can mount Azure file shares, okay, to allow containers to persist their state. Anytime we see those confusing words like mounting file shares and things like that, mounting just means that we are making Azure file share available to the container. That's all it means. So mounting Azure file share, I am making Azure file share available to that container. Again, if I want to store persistent information. Obviously, you can use external caches like Azure Redis cache and things like that. And here in the portal, I can create a container instance resource where I specify the resource group first, and then I provide a name, a region, and here I can choose the image source. So the image source can be just a quick start image from our standard images in the marketplace, and it can be an Azure Container Registry or a Docker Hub or any other registry you are using. In my example, I'm using an Azure Container Registry stored image. In this case, I choose the registry, which is this one, and then the image name, which is test. And then I go ahead and deploy that. What it will do is it will pull the image from the container registry into this container instance, and you would have an application hosted on container instance in a serverless manner. So now let's talk about Azure App Service, which forms a big chunk of the exam. So Azure App Service is a platform as a service on Azure. And essentially, you probably know the difference between infrastructure as a service, platform as a service, software as a service. I don't want to spend too much time on this one, but the way I like to think about it is in terms of control. So the higher you go up the ladder, the less control you are being given. Okay, so with infrastructure as a service, you essentially get the physical hardware, but you still have to manage the updates, the middlewares, the runtimes, etc. With platform as a service, all you have to do is just write the code, and Azure manages the rest for you. And obviously, we have the software as a service, which where essentially everything is managed for you. So Azure App Service is actually one of the first services that were created on Azure. It was previously called Cloud Services, and this is what Azure actually started with. So this platform is actually very useful when you are hosting just traditional classic n-tiered web applications, which can actually be the majority of your use cases. So essentially anything other than microservices is actually recommended to host on Azure App Service. And by the way, you don't need a microservices architecture for every single application. You're actually much better off starting with Azure App Service, which is super easy to work with, and it will give you all those benefits of developer productivity, scalability, and it can handle really a lot of high load. So that's where Azure App Service is used. Definitely, it's more recommended to use Azure App Service than just infrastructure as a service, where you're hosting your application on a VM. This is never a good idea, as I always say. And when you use Azure App Service, you get access to a couple of important features. So the first feature is just built-in autoscale. So you can essentially easily autoscale your applications, where you add more instances depending on a specific condition, like let's say the percentage of the CPU of your host machines. Next, you have the concept of deployment slots, which I will talk more about later. But here you can essentially segment your environments into staging environments, production environments, test environments, etc. Next, you have just the out-of-the-box continuous deployment, short for CD. So you can hook your Azure App Service resource into a source control repository like GitHub, Bitbucket, Azure DevOps, etc. And you just get out-of-the-box continuous deployment with really no effort from your side. Lastly, you also have the ability to host containers on Azure App Service. Next, let me talk about the resource hierarchy. And what I mean by resource hierarchy is how is the Azure App Service resource organized in Azure? So essentially, your Azure App Service resources are organized under what is called an Azure App Service plan. So your Azure App Services are actually created under what is called an Azure App Service plan. Okay. Now, if I zoom into this app service plan, we essentially get this sort of environment. So an app service plan is essentially an environment containing of worker nodes where the applications are actually running, but also there's things like load balancers, which are known as front ends, some file servers and other servers, etc. So this is all a shared environment, or what is called a multi-tenant environment. And what I mean by multi-tenant environment is this environment is actually shared with more than one customers. And actually, most cloud providers go with this multi-tenancy model because it just gives them the best return on investment. This is just the way it works nowadays. But with Azure App Service Plan, you have different level of controls. So if you're going with just the basic tier, every single thing is shared. So the VMs are shared, the load balancers are shared, the file servers are shared. All of this environment is actually shared. But if you go with the production level tiers, everything is shared in terms of networking. So the load balancers are shared, the file servers are shared. All of those actually you don't see them behind the scenes, but the VMs themselves are actually dedicated to you. And this is actually the most important thing, and it actually satisfies most of the scenarios. But with Azure App Service, you also get access to the isolated tier, which essentially gives you your own virtual network, where you can deploy your own load balancers, your own file servers. Everything is essentially for you. So nothing is shared. It's a single tenant. Everything is given to you. So that's the isolated tier, which I will speak more about later on. Now, when it comes to Azure App Service Plan, it defines a couple of different things. Firstly, it defines the region where your applications are hosted. Then it defines the number of VMs you need in your Azure App Service Plan. And lastly, but most importantly, it defines the pricing tier. And when we talk about pricing tier, we have a couple of different pricing tiers. So the first one, which I touched on briefly, is just the shared compute, where All the applications are running on the same single instance, same shared environment. All of the customers are sharing this. Obviously, this is meant for dev test environment, nothing production ready. Next, we have the dedicated compute. And with dedicated compute, you essentially get a shared network, but dedicated instances, as I mentioned in my previous slide. Now, the higher the tier here, the more VMs you can spin up and the stronger the VMs you get, essentially the stronger specs you get. So just to touch on them briefly, we have the basic tier, which does not support Autoscale. We have the standards tier, which does not support private endpoints. And then we have the premium tiers, which do support Autoscale. They do support private endpoints. And the higher you go in versions, the stronger VM specs you get access to. And lastly, you have this isolated environment, which I spoke about briefly, where you essentially get your own dedicated virtual network and instances, where you run this in a single tenant, completely isolated from other customers. So if I want to show you that on the portal really quickly, I have my Azure App Service resource. And under my Azure App Service resource, I can navigate to the App Service plan itself. And as I mentioned, under an app service plan, you can have a bunch of different Azure app services, which represents your applications. So if I go to the apps section here, I can see we have 2 different Azure app services running under this Azure app service plan. And I have a couple of different deployment slots, which I will talk more about later on. So if I want to quickly show you this scale up section, here you can see the different pricing tier, which I spoke about. And Azure makes it really convenient for you where they separate it into dev test, production workloads, and just this isolated workloads. And you have different tiers under those big segments. Next, I would like to talk about diagnostic logging or diagnostic settings, which is actually mentioned a couple of times in the exam. So diagnostic settings is actually a way to send resource-specific logs to either those 3 destinations, which are Azure Log Analytics, Storage Account, or Event Hub. So essentially, most resources on Azure, like Azure App Service, Storage Accounts, Automation Accounts, Event Hubs, etc., they expose certain logging, okay? But you actually don't have access to those logs unless you export them to either of those destinations, which are Log Analytics, Storage Account, or Event Hub. So essentially with Azure Log Analytics, this is best used if you just want a query mechanism where you want to query your logs. You want to create things like alerts where you want to respond to the logs. You use Azure Log Analytics for that. But if you just want those logs for archival reasons, you typically just throw them into a storage account. Lastly, you have the Event Hub, and this is meant for having applications consume those events or those logs. So you can essentially have like diagnostic settings configured on an Azure App Service where it sends logs to Event Hub, and you would have another application, let's say Splunk, which is a third-party logging system that consumes those logs where you can query them later on. So again, just a couple of different use cases here. But with Azure App Service resource specifically, there are a couple of different logs that you can expose and export to those destinations. So the first one is just the application logging, and here you can see all the descriptions. These are basically just the log messages generated by your application code. You have the web server itself logging, so those are the raw HTTP requests. You can have detailed error logging, failed request tracing, and deployment logging. And here you can see what platform is supported for that. And if I want to show you that on the portal, if I can scroll down here and go to diagnostic settings, as you can see here, you can configure a couple of different endpoints. So basically, if I click on add diagnostic settings, I can choose either of those endpoints. This is sending to a partner solution. This is actually recently being developed, but essentially you can actually choose those logs that I spoke about in my previous slides. So this is where you create the diagnostic settings. These are the categories that you choose. And here is the destination that you configure. Okay, pretty simple stuff here. Next, I want to talk about deployment in Azure App Service. So how do you deploy your code to Azure App Service? So essentially you have 2 methods. The first and the recommended one is the automated deployment. And here you have out-of-the-box integration with a source control repository like GitHub, Azure DevOps, Bitbucket, etc. So anytime you merge changes into a master branch, the code actually gets deployed automatically to Azure App Service. So in other words, anytime you make changes to a source control repository, those changes are actually deployed to Azure App Service automatically. And this is actually the recommended way to go about this in production environments. Next, we have just a simple manual deployment, and where you just have your application code. You can use Azure CLI for that. You can use zip deploy using our Kudu API. You can transfer it through FTP, and you can also deploy it from Visual Studio, which I find is the most convenient method for that. So if I want to show you a quick demo on how we would deploy the code to Azure App Service using Visual Studio Code in this example, you would have to install an extension called Azure, and then once you install that extension, you would have access to this tab. And essentially all you have to do is just click deploy to web app. So you would choose the folder where your application code is written in, and then you would choose the subscription, and then you would choose the specific web app itself. In this case, it's this one, and it will just automatically deploy it. Next, if I want to talk about the automated deployments, which is from a source control repository, all you have to do is just go to Deployment Center, and all you need to do is just hook up your app service resource to a source control repository. In this case, here I'm already connected to a source control repository in GitHub. I have my test repo repository, and I'm choosing the main branch. So now, anytime I make changes to this main branch, or anytime I merge changes to this main branch, the code will get deployed to Azure App Service automatically. And again, this is the recommended way to go about deployments on App Service. Next, I want to talk about the concept of deployment slots. So I touched on the resource hierarchy on Azure App Service a bit, but if I want to expand on this a bit, we have the Azure App Service plan, and underneath that App Service plan, we have the Azure App Service resource. And under that Azure App Service resource, we have what is called deployment slots, which are actually the place where, or the slots where your application is actually running. Okay, so you can have things like production slots, which are there by default without you having to do anything, but you can create extra slots like staging slots. So essentially, you can deploy your application into those specific slots. So the unit of deployment in Azure App Service is actually the slot itself. It's not the App Service plan. It's not the Azure App Service resource itself even. It's actually the deployment slot. Okay, so you can deploy your application into a production slot, into a staging slot, and there are many different use cases for that. The most common use case is obviously anytime you want to deploy into production, it's never a good idea to deploy immediately into production because there's always downtime for that. The way this works is you would first deploy it into staging. You would make sure everything is working fine in the staging environments, things are not breaking, etc. And then only after that, you would swap the staging environment with the modified code with the production environment. Okay, so essentially once you swap that, all it does is just a DNS entry change, nothing more than that. So you won't experience any downtimes. You will have more confidence because you actually deployed your application to a staging environment. You made sure that you did not screw things up. And look, if you end up screwing things up, you can just go back to the previous slot. So essentially all of that is easily managed in Azure App Service. But one of the interesting things you can also do is things like A/B tests. So you can essentially divide traffic between your slots to do things like A/B tests. So you can have 50% of the traffic go into production and the other 50% of the traffic go to production 2, for example. And if I go back to the portal and I go to the deployment slots section, in this case, you can see 2 different slots here. So automatically you will get the regular slot, which is the production slot, but you can optionally add new slots. In this case, I have this staging slot. And if I click on this staging slot, it's actually just like a different app service resource, essentially. Like from a UI experience, it looks like it's a different Azure App Service resource, but it's actually under the same Azure App Service. It's just a different slot. So again, you deploy your application into a slot, whether it's the production, whether it's the staging one. So best practice is you would have your code, you make the changes, you deploy it into the staging environment, you make sure everything is working fine, and at the end, all you do is just swap it with the production environment. And if you screw things up, you can just swap it back again. Your users will not be impacted at all. And as you can see here, here's where you control the traffic. In this case, 100% of the traffic is going through to production. Lastly, a very important topic to talk about in this exam is Autoscale. Okay, now there's a very small disclaimer here that I've written, which is actually something that a lot of customers get confused about. So Autoscale does not solve all your problems. Okay, just because we have Autoscale, that does not mean that it's going to solve all your problems. It's going to give your users the best experience. You don't have to worry about anything. So Autoscale helps when the server itself cannot handle the number of requests, okay? But it doesn't help with resource intensive tasks. So let me explain that. So usually Autoscale is helpful when there's literally not enough TCP sockets that a server can handle, okay? That's useful because you can just spin up extra servers, your users won't get impacted, new requests will still be served, okay? But if you have resource intensive tasks on a very weak machine, adding more machines is not going to make a difference because those machines are essentially just weak. Okay, so I hope that makes sense. In a nutshell, Autoscale is super helpful when you are dealing with a very high traffic, but it doesn't mean like you can choose a very low VM spec and you can just configure Autoscale and have things easy for you. You do need to think about this a bit. So it's not as straightforward as people think it is. So Autoscale resource on Azure, okay, is actually under the resource provider. Remember, we spoke about resource providers before. It's under the Microsoft.Insights resource provider, okay? So it's essentially just an Azure resource, just like Azure App Service, just like storage account. At the end, Autoscale is just a resource on Azure. That Autoscale resource on Azure can be configured on a couple of different resources, okay? So in other words, it can scale a couple of different resources on Azure. So those can be API management, those can be Azure App Service, those can be just standard virtual machines. So again, it's just a different resource on Azure. It's like it's applied on the Azure App Service resource itself, but it's not essentially tied to it, if it makes sense. It's a completely different resource provider, okay? So the Autoscale resource itself, with that, you create rules based on those condition types. So you can autoscale based on a metric, okay? So essentially you make decisions based on a certain metric. That metric can be the percentage CPU on an app service plan. It could be the number of HTTP requests, etc. So you're essentially making decisions based on a metric, okay? But you can also scale to a specific instance count based on a schedule, okay? The perfect example is Christmas time. Look, your store is crazy, has crazy traffic during Christmas time. You don't want to make auto-scaling decisions based on a metric because you just know that during Christmas, you just want more instances running just in case, okay? So you can configure a rule where you scale to a specific instance count based on a schedule, not a metric, okay? Also, spoiler alert, you can actually configure it based on both conditions. So you can have a condition where you scale it on a metric. You can have another condition where you scale it to a specific instance count. So you can have both under the same auto scale setting, okay? And multiple conditions are actually treated as an or, not as an and, okay? So it's either or, okay? And if I want to demo that quickly on the portal, I would go to, if I search for auto scale here, I would go to scale out, okay? So under scale out, I can configure the auto scale setting. So there's manual scale where I can just choose the instance count manually, or I can have custom auto scale, which is the auto scale that I've spoken about, okay? And you would give it just a name, under a resource group. Again, this is just a resource on Azure. And then you would choose whether you want to scale it based on a metric or to a specific instance count. So if I want to scale based on a metric, I would add a rule here under add rule. And here you can choose the metric source. That metric, by the way, can be any resource on Azure. It doesn't have to be an Azure App Service metric. You can actually make decisions on a metric, on a virtual machine metric, which is completely different. I know that sounds crazy, but you can actually do that. So you can choose any metric on Azure. Obviously, it's typically used for the actual Azure App Service metric because that is what you are designing on. But usually you can have it on the actual App Service plan or the Azure App Service resource itself. Okay, so you have both options. Essentially, here you would choose the App Service plan, the aggregation, and then here you choose the different metrics. So it could be CPU's percentage, data in, data out, and then here you would define basically the threshold. Okay, so let's say if it's more than 70%, you want to increase the instance count, let's say by 2. Okay, and then you would have a cooldown time. Okay, the cooldown time essentially in this case it's 5 minutes. What this means in a nutshell is anytime the auto scale rule is triggered where it adds some instances, it takes some time for that to be adjusted. Okay, so there's typically like a cool down period after that for like 5 minutes which basically instruct the Autoscale to not make any decisions for those 5 minutes. Just like when you cool down after your workouts. And obviously here you can scale to a specific instance count. You could have that, and then you would create a schedule based on that. Again, super simple, super intuitive to navigate with. Let's talk about Azure Functions. So Azure Functions is the serverless offering on Azure that allows you to run event-driven functions. Now, as you can see, there are a lot of terminologies here. So let me break them down one by one. So what do we mean when we say serverless? So when we say serverless, that does not mean that servers are not used. Obviously, there are servers always behind the scenes. But when we say serverless, what we mean by that is you don't have to think about the hardware at all. Okay, so the platform takes care for you. So essentially with Azure Functions, all you have to do is just write the code and that's it. Okay, it's the same with Azure App Service. So you just essentially write the code, but on Azure App Service, you still have to choose like the VM specs, which tier you want to use, based on the VM specs, etc. So you still have to think about servers. Okay, with serverless, essentially it means that you don't have to worry about the servers at all, and it handles things like scale for you without having you actually worry about that and using certain rules, etc. So it's essentially just a layer of abstraction above platform as a service. So it's between platform as a service and software as a service. Okay. Now, what do we mean by event-driven functions? So serverless is best used for event-driven applications. What do I mean by event-driven applications? Is applications that respond to something, or specific functions that respond to something. So that can be a blob storage upload. That could be a database record addition. That could be an API call. So anything nowadays is considered event-driven, and Azure Functions are perfect when you want to execute something specific in response to an event, while not having to think about any servers at all. So that's in a nutshell what Azure Functions is. Okay. Now, with a more technical terminology, serverless means it's consumption-based. Typically, it means that it's consumption-based, meaning that you only pay for what you use. Okay. Second is you don't have to worry about servers at all, which is what I've explained previously. And lastly, it scales automatically out of the box. You don't have to configure anything. Everything is done out of the box. Now with Azure Functions, you have a couple of different hosting plans. So I've organized it into hosting plans on the left and the use case for that, okay? The first and most common use case is the consumption plan, okay, which actually qualifies as a serverless platform. This is the default one, and you basically pay for exactly what you use. Super cheap. I think you get like 1 million executions per month for free. So it's super cheap. It's the default one. You pay for exactly what you need. And the maximum timeout in this is 10 minutes per function. So you can't go more than that. There's no virtual network integration with that. And it has what is called as cold starts. So because you only pay for what you use, the Azure Function app itself can scale down to 0 when there's no usage. And because it scales down to 0, once it's used again, it takes some time to spin up and provision the resources to accept the requests. Okay, so if your functions are super sensitive and you don't want them to be prone to cold starts and you want them to be executed immediately, you would have to look into other plans. So here the use case is you don't need the features of other tiers. That's basically it. So you want to pay for what you use and you don't want the features of other tiers, which I will touch on now. So we have the premium plan, okay, which is the second tier. And here you get predictable pricing per month. So this is what you're used to with app service, with VMs, etc. You get essentially predictable pricing. Okay, some customers prefer that. But most importantly, you get no timeouts. It supports VNet integration. And the most critical one is that the instances are pre-warmed. Okay, so the function execution is immediate. There are no cold starts. There are no things like that. But you would have to pay a fixed monthly fee no matter how much you're using the function. Okay, so this is different than the consumption. The use case for that is short but frequent executions. Okay, so if you have a lot of short but frequent executions, you don't want things like cold starts. You want pre-warmed instances. So this is a good use case for that. Okay. Another use case is you want seamless access to VNet resources. You would use premium plan because there is VNet integration. Lastly, we have the dedicated plan. Okay, now the dedicated plan, it essentially runs the function app itself in an Azure App Service plan. Okay, simple as that. Same as you would run Azure App Service on an App Service plan, you can also run Azure Functions on an App Service plan. Okay, You have no cold start issues because obviously, you're using it in an app service plan. Okay, the instances are already there. There are no timeouts, etc. So the use case for this is underutilized app service plan. So if you have an app service plan that's strong enough, it's underutilized, feel free to use it for your function apps as well. And another good use case is actually having Azure functions in its own VNet. So Azure function itself is actually not deployed in a virtual network. So with the consumption and premium plan, the function itself is not deployed into a virtual network that you control. Okay, but with dedicated, you can run it on an app service plan under an isolated tier. And the use case for that is you can run Azure functions in its own VNet. Okay, so if this is a requirement for you, this is a good option to go with. Next, I want to talk about the resource hierarchy of Azure function apps. So the way this works is you still have an app service plan. You don't deal with that a lot. You typically just do that to configure some network things like VN integration and things like that. But the bulk of this is you have a function app resource, and under that function app resource, you have different functions, okay? Different code functions, okay? Now, usually I've seen customers use just one function per function app resource, okay? Similar to how you would use like one app service resource under one app service plan, okay? This is similar, but essentially you would have multiple functions under the same function app resource as a way to organize similar functions together. So that's the way it's used. And if I want to show you that on the portal super quickly, I have the function app resource itself, and under that I have two different functions that I've created, and I can see that I can go also to the app service plan itself, and I can see the in this case like the function apps that are underneath this app service plan. So not the functions, the function apps themselves. And here I can configure things like VN integration and things like that. I can scale it up by changing the tiers, so from consumption to premium, etc. There are some restrictions from changing from premium back to consumption, so that's something to be aware about. And here with the scale out, notice that you don't have any autoscale rules or things like that. Like what you can do is basically just control like the maximum number of instances and the maximum burst. Okay, so you don't have any like metric conditions, schedule conditions, etc. Everything is handled out of the box. Next, let's talk about triggers and bindings. So on Azure function, we have the concept of a trigger, which is the thing that triggers the function itself. And you can only have one trigger per Azure function. Next, we have what is known as bindings. And this is a way to declaratively define inputs and outputs from your Azure function. So it's simply just a way to make it easier to connect to different Azure resources. Okay, so this will make more sense in this diagram here. So a simple example is having a service bus queue trigger. So in this case, anytime a message is written to this service bus queue, the Azure function will be triggered. Okay, so this is an example of a trigger. Okay, now here we have a couple of output bindings for this Azure function. So in this case, it's Cosmos DB output binding and Event Hub output binding. And when you declaratively define those in Azure functions, it just makes it super easy for Azure function to connect to those Azure resources. So you don't have to rely on the Azure SDK and configure all of that by yourself. Bindings just make it super easy to natively connect to those Azure services in a seamless way. So here on the right, you can see a couple of different examples. So whenever a new queue message arrives, it runs a function to write to another queue. In this example, the trigger is a queue and the output binding is also a queue. Here you have a scheduled job which reads from blob storage contents and creates a new Cosmos DB document. In this case, the trigger is a timer because it's a scheduled job. And the input binding is blob storage because you are reading from blob storage. And the output binding is Cosmos DB because you are creating a new Cosmos DB document. Okay. Now, certainly in your function code itself, you can just use the Azure SDK and connect to blob storage and connect to Cosmos DB documents, but but bindings just makes this experience like just super easy to start with. So here is a quick example of how bindings are actually created. So in most programming languages, it's actually created using a JSON configuration file. Okay, so in this example, it's a Node.js file. If it's C#, it actually uses a decorator to create that. So in this example, I have an HTTP trigger with a direction of in. Okay, and I have an HTTP output binding. And the reason why I have an HTTP output binding is because I want to respond back to the client with a specific JSON body. That's why we have an output binding as well for HTTP. But in this section, we also have the output binding for Cosmos DB. And how do you know that? It's from the type, which is Cosmos DB. And this is all from the Azure documentation, by the way. And here you define the direction, which is output. And this gets translated into this diagram here, where you have an HTTP trigger triggering this Azure function, which then does some logic and then writes to a Cosmos DB resource on Azure. And if I want to show that experience in Visual Studio Code, you can actually develop your Azure function resources, obviously on Visual Studio Code, and you'd have a very nice experience for that, where you can debug it on Visual Studio Code, you can run it locally, etc. So in this case, I have 3 different Azure function resources, and underneath this specific Azure function resource, I have 2 different functions. So one is called blob trigger 1, the other is called HTTP trigger 1. Okay. Now, there are 2 important files that you need to take into consideration. The first one is the host.json file, which is a global config file that is applied to all functions under an Azure function app resource. So things that can be defined here is essentially, for example, like number of concurrent HTTP connections, like the sampling in app insights, etc. So it's just a global config file that's applied to all functions under the same Azure function app resource. Next, we have the local.settings JSON. And here you define things like your connection strings, your secrets, etc. Again, it's just a config file that's that allows you to read from it using, like, let's say, connection strings and things like that. This will make more sense once I demo the binding part. So if I open blob trigger function itself, I can go to index.js, which is actually the main logic of the Azure of the function itself. In this case, all I'm doing is just I'm writing some records to the Cosmos DB resource, and I'm accessing this Cosmos DB resource by accessing the bindings object. Okay, and that bindings object is inside this function.json file. Okay, inside this function JSON file, again, we define the trigger, we define the binding. In this case, I have an HTTP trigger. Okay, and I have an output binding of Cosmos DB. Okay, and as you can see here, it's type Cosmos DB and the direction is out, and we have a connection string called my account Cosmos DB, meaning when I run this function app locally, the connection string will actually be read from the local.settings.json. Okay, so that's different than when in the cloud. I'll show you how that gets read from the cloud, but in the case of running it locally, we read the connection strings from this local.settings.json file. Okay, so I can essentially run this locally, I can debug this locally, and I can do everything locally, essentially. And again, I can deploy this function itself to an Azure function app resource by using the Azure extension of Visual Studio Code, just like we did with Azure App Service. And we can also connect it to a source control repository like GitHub to have an automated deployment. Everything is exactly the same experience as Azure App Service, but the difference is this is a specific function. And if I go back to the portal, once I deploy these, I will actually see them under the functions blade. So as you can see, I have the blob trigger function and I have the HTTP trigger function under this function app resource itself. And I can essentially test it from the cloud as well. So if I click on this specific function, I can go to code plus test, and I can test this specific function itself. So if I click on test/run, I can essentially run this, and you can see this should work. So saying thanks for reaching out, because this is the message that I've configured. So you can test things out here, etc. Now, the question is, how do we read that connection string that we have on the bindings file or the function.json file? Okay, if we go to configuration, we can see where the connection strings are actually configured. And you can see those connection strings here. So this is the my account underscore Cosmos DB, which is used by the application. So again, we use the configuration under the settings here for any cloud deployments, and we'd use the local function.json file if we want to use the connection strings locally. Now let's talk about Azure Durable Functions. And Azure Durable Functions is a way to create complex orchestrations and workflows using code. So if you are familiar with a service like Azure Logic Apps, which allows you to create workflows using a GUI interface, Azure Durable Functions is exactly the same, as in it allows you to create those workflows and complex orchestrations, but using code. Okay, so traditionally, Azure Functions is actually a stateless system. So it doesn't make sense to store state in Azure Functions and use that state to make certain decisions in your code logic, okay? And the reason for that is because you don't have control over the instances themselves. Sometimes the instances spin up, they change from one instance to the other, so it's never a good idea to store state in Azure Functions, okay? The best practice is typically to use like an external storage like Redis cache, for example, if you want to store states and then make decisions based on those states. However, Azure Durable Functions makes it easy to create stateful functions, which allow us to create those complex orchestrations and workflows. And in fact, Azure Durables is actually, a durable function is not magic. It's just a library. So it's not a feature on Azure Functions. It's simply just a library that allows you to develop stateful functions. Okay, that's all it is. Nothing magic behind the scenes. Okay, so behind the scenes, the state is actually managed for you, okay? Now, this will make more sense once I demo this, but the common use cases when you wanna take state as an advantage is, for example, with function chaining, okay? So with function chaining, you can use an output of one function as an input to another function. Now, essentially, you need to store state with that. And with Azure Durable Functions, this makes it super easy, or this whole process is made super easy, okay? Now, the other common pattern is called fan out, fan in, where you can essentially execute multiple functions in parallel where you want to aggregate something, and then that aggregation is used in a single function, okay? Trust me, things like these are actually super difficult to develop, okay? So Azure Durable Functions make this experience super seamless. So things like fan out, fan in actually takes a long time to develop, and it's super complicated to actually get right, okay? So again, Azure Durable Functions, in a nutshell, it's just a library that allows you to write stateful functions, which can then allow you to write complex orchestrations and workflows, just like you do with Azure Logic Apps, which is GUI based. Now, what are the components of Azure Durable Functions? Again, this is just a library, and typically with Microsoft, we provide you those starter templates and you can build on top of these, okay? So in this example, I have an Azure Durable Functions taken from the Azure documentation. And in this example, I'm actually using the function chaining example, where I'm using the output of one function as an input to another function, okay? This is the file structure, and those are the components that make up Azure Durable Functions. So the first component is the orchestration functions. And the orchestration function is the function, again, from the name, it orchestrates things, okay? Now, the activity function is actually the function that actually contains the majority of the logic, okay? So in this case, it's hello one. Finally, we have the starter function, which actually starts the orchestration, okay? Now, the question is, how does all those three work together? So you typically have a starter function, which starts the orchestration function, and that orchestration function calls the activity function or orchestrates the activity function, which contains the majority of the logic. So if I go back to Visual Studio Code, I can see this is the orchestration functions. So as you can see here, I am using the first example of the durable function, where I'm using the input of one function as an output to another function. So in this case, I'm calling the hello function 3 times. Now, this hello function is actually the activity function, which is defined here under this hello one folder, okay? So essentially what's happening here is I'm calling this hello function and I'm providing Tokyo as an input. And then once that is done, I will call the hello again and then provide it Seattle. And then once that is done, I will use this as an output to the third function, etc. Okay. And here, as you can see, this starter function, which actually starts the orchestrator. Okay, so that's the way this works. And behind the scenes, the state is actually stored on Azure Storage. Okay, so all of that magic actually happens on Azure Storage, all of those states, the execution history, and things like that. So last but not least, we have the final topic in Azure Functions, which is Azure Functions Custom Handlers. So custom handlers are just a way to run Azure Functions using unsupported languages by offloading that work or that process to an external web server. So this diagram is one that I took from the official documentation, and I think it explains it pretty well. So the way this works is the function host itself will offload that request payload to an external web server that's maintained by Microsoft. And the code is ran in that web server, and then the response payload is given back to the function's host, which must be able to parse that JSON and handle that response itself. So essentially, with this experience, you are not limited with just the supported languages that Azure Functions support. Okay, so you can develop with things like Go, Rust, and even Deno in the case of TypeScript. So really, the sky is the limit here, and it's basically the same experience as using a regular Azure function. And when you first create the Azure function, you don't have a choice of choosing an unsupported language, obviously. So typically the Microsoft recommendation is just to choose .NET Core as the stack, okay? And then Microsoft will take care of it. So you can essentially use custom handlers like Go, Rust, etc.